Hi. So here we have to figure out the number of real roots of this equation, right? So let's just focus on this part here. The right hand side is 2 to the power x plus 2 to the power minus x is effectively 1 upon 2 to the power x, right? Now 2 to the power x will always be a positive number, right? So 2 to the power x, so what we have here is a number, positive number, plus its reciprocal. Now we know a number and its reciprocal, a positive number and its reciprocal, the sum of these two will always be greater than or equal to 2. So any positive number and its reciprocal is always greater than or equal to 2. We have seen this using am greater than or equal to gm property, right? So 2 to the power x plus 1 upon 2 to the power x will always be greater than or equal to 2. And this is equal to 2 into cos of x into x plus 1. So 2 into cos of x into x plus 1 is greater than or equal to 2. That means cos of x into x plus 1 is greater than or equal to 2 by 2 1. Now is it possible for cos to be greater than 1? No. Cos of any angle will always be 1 or less than 1. It is always between minus and 1. Minus 1 and 1. Cos of a number is always between minus 1 and 1. So obviously it cannot be greater than 1. So the only thing that we have, only possibility is that cos of x into x plus 1 should be equal to 1. This is the only possibility that we get, right? So here we need equality, and equality we know happens when both these terms will be equal. So if a plus 1 upon a is greater than equal to 2, they will be equal to 2 when a is equal to 1. When a is equal to 1 upon a, that is when a is equal to 1. Hence here equality, as in this thing, will be equal to 2 when 2 to the power x is equal to 1. Now for what value of x will 2 to the power x be 1? When x is 0. Only for x 0, 2 to the power x will be 1. And when x is 0, so we have x of 0 into 1 is 0, cos of 0, and cos of 0 we know is 1. Hence x equals to 0 satisfies both these conditions given. The only possible solution of x that we get is 0. Hence we have to figure out the number of real roots. We don't have to tell what is the root, we have to tell how many real roots are there. So there is only one real root, so the answer here is option D. We get the real root from this condition. First we figure out that this will be true only when we have equality in am greater than equal to gm rule, and equality occurs when a is equal to 1. Hence when a is equal to 1, we figure out that x is equal to 0, and this is the only possible value of x. Hence the number of real roots is 1. Thank you.